Hi, Margaret. I came up with a couple of problems that have to do with reactions and stoichiometry and solutions. So this is one I found from my book, and this should be familiar to you compared to the last video I made. Here you've got a strong acid, nitric acid, with barium hydroxide. Barium hydroxide happens to be not very soluble, but it does react with acid directly. So the question is, what volume, how much of this acid do you need in milliliters to completely react with 2.5 grams of barium hydroxide? Well, this 2-to-1 ratio that's inside the question here, I didn't do a very good job of doing that, basically the 1 is implied, means that I need twice as many moles of nitric acid compared to however many moles of barium hydroxide I have. So let's figure out how many moles of barium hydroxide we have, and then we could go from there. So 2.5 grams of barium hydroxide convert to moles, so 1 mole of barium hydroxide weighs, whoops, I should have my periodic table handy. Barium is 137.3, and hydroxide plus 32 plus 1.01, I get 170.3 grams. And the number of moles is 0.0147 moles. Now, notice the 2-to-1 ratio. So, whoops, that's a 7. The 2-to-1 ratio from the balanced equation means that I have to do this. 2 moles of HNO3. And so my number gets doubled, and I get 0.0294 moles of HNO3. The question was, though, how many milliliters? Let us go back to the very beginning, and I tell my students, and I'll tell you, that a molarity is a conversion factor. It doesn't look like it necessarily, but it really is. So when you say a molarity is moles per liter, you could use that as is or written upside down if you need it. And here we need it upside down. So 0.109 moles HNO3 per liter. And then when I do that division, I'll have my answer in liters, 0.269 liters of HNO3, and I can convert that to milliliters just by moving the decimal point. Okay, so that's the answer to this question. Double check my math. I think I got it right. That does seem like a large number, but I think it looks good. All right. Alternatively, you could ask, I had another question that was similar, and the equation was also an acid base. Here it was sodium carbonate. You should recognize the sodium carbonate as a soluble salt, so I'm going to put AQ. And this one also reacts with a strong acid, just like the last problem. And then if I do an exchange reaction here, you might remember that when strong acids react with carbonates, you get CO2 plus water. So I'm going to get 2 sodium nitrates plus CO2 gas plus water. This question asks, what's the mass in grams of sodium carbonate that will react completely with 50 mLs of 0.125 molar nitric acid? Well, just like the last problem, if we know how many moles we were given of the nitric acid, we could use the balanced equation to figure out how many moles of sodium carbonate and then go to mass. So remember, volume times molarity equals moles. So my volume in liters, 0.050 liters, times the 0.125 molar is going to give me my moles of nitric acid. 0.05 times 0.125. I get a pretty tiny number, 0.00625 moles of the HNO3. 0.00625 moles of HNO3. What's the ratio from the reaction? Well, it looks like it's 1 to 2. So 2 moles of HNO3, 1 mole of Na2CO3, and that means I get 0.003125 moles of Na2CO3. The question asks, though, for mass in grams, so I'm going to need the molar mass, which is probably going to take me a minute or two to calculate. I'm going to do that on my calculator. And let's see, 2 times 20. This is definitely going to be rough, but I got about 106. And so that number times 0.003125 gives me 0.331 grams Na2CO3. All right, so check my math on both of these, see if I got them right, and I'll be happy to make any more videos if you ask. Bye.